In this lesson, we want to talk about verifying trigonometric identities. All right, so in this particular section, you might struggle a little bit when you first get to it. It's a topic that you really need a lot of practice with. It's not as straightforward as other topics where you have a set list of things that you need to do, okay? If you were solving basic equations, I could give you the steps and you could perform those steps and basically you would get the right answer all the time. With this, there are just hints or strategies you can use to arrive at the correct answer, but it's not so clear in terms of what you need to do, and there's also multiple ways to do the same thing, okay? So I have some little tips here for you, and they're standard from any textbook, okay? So you'll get this in any textbook. The first thing is to memorize the fundamental identities. So again, in the last lesson, we talked about these fundamental identities, and we talked about simplifying trigonometric expressions using the fundamental identities. Again, we looked at a little handout here, so hopefully you have that again, and you want to memorize these. So you have the reciprocal identities, you have the quotient identities, the Pythagorean identities, and then you have your negative angle, or again, some books call this even odd identities. So all of these are going to play a crucial role when you're verifying these trigonometric identities, okay? So here are some other tips. You always want to try to work on the more complicated side, okay? So when you're verifying trigonometric identities, you're not going to be doing the same thing as when you solved equations. When you work with equations, you might multiply both sides by the same number or add the same term to both sides, something like that. Here, you're not going to do that. You're going to work on one side, generally speaking, the more complicated side, and try to make it match the other side, the simpler side. Okay. Another tip is sometimes you'll want to express everything in terms of sine and cosine. That doesn't always work, but it's just a general tip. Okay. You want to perform any indicated algebraic operations such as factoring or expanding. Here you want to think about all those special product formulas, okay, and all the special factoring formulas. Those are going to come up a lot. And then we have use the formula for multiplying conjugates. So remember, if you have 1 plus sine of x times 1 minus sine of x, this is going to be 1 squared, which is 1, and then minus sine squared x. So basically 1 minus sine squared x, and we know from our Pythagorean identities, this is going to be exactly equal to cosine squared x. Similarly here, I could make this 1 minus cosine squared x, okay? And that's going to be exactly equal to sine squared x. Okay, so let's take a look at the first example. And the first few of these are going to be really, really easy. So go ahead and pause the video and try them on your own once I kind of get going here, and then see the solution. So the first thing is I'm going to think about which side is simpler. So to me, this side is simpler, okay? So I'm going to try to work on this side on the left. Now, pretty much every book that you're going to see has different formatting. Generally speaking, they sometimes will take this guy right here and just work on the more complicated side, and at the end, they'll show you that it matches. What I'm going to do here is I'm just going to take this guy and flip it. So I'm just going to say I have 1 plus sine of x is equal to, over here I'm going to have cosine of x plus cotangent of x, okay, over the cotangent of x. I'm flipping it because what I'm going to do is modify the right and leave the left alone. Okay, so that's generally the formatting you're going to see. If your teacher tells you to do something else, then follow that. Okay, so what I'm going to do is just put equals over here. I'm not going to mess with this. My goal is to get this side right here to match this 1 plus sine of x. So the first thing I'm going to do is I'm going to write things in terms of sine and cosine. So I have cosine here, okay, so I'm not going to touch that. But cotangent of x, again, if you think about the reciprocal identities, it's cosine of x over sine of x. So I'm going to start by saying I have cosine of x plus cosine of x over sine of x. And this is over, again, if I have cotangent of x, I'm going to write it as cosine of x over sine of x. Okay, let's scroll down and get some room. We'll come back up when we get to a stopping point, okay? So what I want to do here is think about the fact that I have basically a complex fraction, right? So how do you simplify that? You look at the denominator, so I have sine of x and sine of x. So if I multiply this by sine of x over sine of x, basically I'm going to distribute this here and here, okay, and I'm going to distribute this here. So I'm just going to keep my equals over here, okay? We might need more room, so let me just kind of slide this down a little bit. Sine of x times cosine of x is just sine of x times cosine of x. Then plus sine of x here would cancel with sine of x here, so I just have cosine of x here, okay? Then down here, this sine of x here would cancel with this sine of x here, so I'm going to put this over just the cosine of x, Okay, so let's go down a little bit more and let's think about something here. We have the cosine of x and the cosine of x. What operation could I do there? Well, I could factor, right? So I'm going to put equals here, and I'm going to pull that guy out, okay? So I'm going to say I have the cosine of x. Inside the parentheses, I'll have the sine of x, okay? Plus, if I pull this out, I have a 1, okay? Then this is over the cosine of x. And now what I'm going to do is I'm going to cancel this with this. And what I'm left with is going to be the sine of x plus 1, okay? If we go all the way back up, we see here that we have 1 plus sine of x. And here we have sine of x plus 1, right? So I could write this as 1 plus sine of x, okay? And then I'm just going to put a big check mark here to show that this right side now here matches the left side, okay? So you could have gone about this a different way. There's multiple ways to verify a trigonometric identity. The main thing is, again, start with the more complicated side, work your way down, okay, and try to make it match the other side. Okay, so once you've found that it matches, you're done. Put your check mark and move on. Try to make your steps as clear as possible so that whoever is grading it can give you full credit. Okay, let's take a look at another example. This is another kind of easy one. So we have the cotangent of theta over sine squared theta equals cosecant squared theta over tangent of theta. Now, in this particular case, both sides are equally complex. So I'm just going to leave the left one alone because it already contains sine, okay? If you wanted to do it a different way, again, that's fine. So I'm just going to basically put equals here, and I'm going to manipulate this in terms of sine and cosine. So cosecant, okay, if I think about the reciprocal identities, is 1 over sine. Okay, so basically, I can say cosecant squared of theta is 1 over sine squared of theta, okay? And then over tangent of theta is going to be my sine of theta over my cosine of theta, okay? So what I want to do here, think about the fact that you are basically going to flip this guy, okay? Basically, if you're going to divide fractions, you multiply the first fraction by the reciprocal of the second guy, okay? So let's scroll down a little bit. And I'm going to go 1 over sine squared theta times, this is going to flip, so it's going to be cosine of theta over sine of theta, okay? And can anything cancel here? Well, no, you might be expecting to cancel sine of theta. So at this point, you might stop and say, well, what's going on? So let's go back up here, okay? Let's think about what we have. We have cotangent of theta over sine squared theta. Well, I have sine squared theta here. This right here, if you really think about your reciprocal identities, remember cosine of theta over sine of theta is cotangent of theta. So I can replace that, okay, I can replace that with cotangent of theta, okay, so I can put 1 over sine squared theta like this, multiply it by cotangent of theta, okay, and basically we're done, right? All we have to do is multiply this through and say I have the cotangent of theta over sine squared theta, okay, so now your left side and your right side are going to match, so you put your check mark there. Again, just make sure you show your steps so your teacher can give you full credit. All right, for the next one, we have the negative of cosecant squared theta times cosine squared theta is equal to 1 minus cosecant squared theta. So for this guy, you might be thinking that the right side is a bit more complicated. It looks kind of like the difference of squares, right? So it is, actually. You could factor that if you wanted to. But I'm not going to do that. I'm going to leave this side alone. Whenever I see something that looks like this, I'm thinking about the Pythagorean identities. I have a minus or a plus with a 1 here, and this is squared. If I look at my little handout here, I want you to think about this one right here. So 1 plus cotangent squared theta is equal to cosecant squared theta, okay? So we'll come back to that in a moment. And I'm just going to work through this. I'm going to flip the sides here. I'm going to put 1 minus cosecant squared theta, okay, is equal to, I'm going to put negative cosecant squared theta times the cosine squared theta, okay? So what I'm going to do first is just take this side right here and express it in terms of sine and cosine. Again, for a lot of these problems, that ends up being all you really need to do to end up with a solution. So I'm going to put equals over here. I'm going to change this. I'm going to put my negative out in front. Cosecant squared theta, again, with the reciprocal identities, I can put 1 over sine squared theta, okay? This is times cosine squared theta. And then over here, I have the negative of, I'll say, cosine squared theta over sine squared theta. Can I make a replacement here? Yes, because this guy right here is the cotangent of theta, right? So basically what I have, let me scroll down a little bit, is the negative of the cotangent squared theta. Now, can I do anything with this? Remember, I talked about this Pythagorean identity here, okay? Let's assume I moved this over here and this over here. So basically I would have 1 minus the cosecant squared of theta is equal to the negative of cotangent squared theta. So right now I have the negative of cotangent squared theta, and I can replace it with exactly this right here, 1 minus cosecant squared theta. Okay, so that's what I'm going to do. So I'm going to say this guy right here is 1 minus the cosecant squared theta. Okay, so now my left side exactly matches my right side. I'm going to put my check mark there, and I'm done. All right, let's take a look at a harder example. So here we have 2 times the tangent of theta times the secant of theta is equal to 1 over 1 minus the sine of theta minus 1 over 1 plus the sine of theta. So when you see this guy right here or this guy right here, you got to be thinking about conjugates, okay? So I'm definitely going to leave the left side alone, and I'm just going to play with this right side. Before I do anything, I just want to do this off to the side so I have a lot of room to work. I know that I would want to get a common denominator here. Okay, so how would I do that? Again, I'm thinking about conjugates. So here I would multiply by 1 plus the sine of theta. Okay, here 1 plus the sine of theta to make that legal. Again, this is 1. I can multiply these together. So you see how this formula is going to work. If you had a minus b, that quantity, times a plus b, this quantity. Remember, this is a squared, first guy squared, minus b squared, minus the second guy squared. Okay, in this case, it's going to be no different. This is going to end up being 1, the first guy squared, then minus, you have sine squared theta, so sine squared theta, this second guy squared, okay? So up here, this would just be 1 plus sine of theta, okay? You can get rid of this, and then down here, this is going to be 1, you don't need 1 squared, minus the sine squared theta. Okay, so that's going to be this part right here. For this part right here, I have a plus here, so basically, this part is going to be a minus. So I'm going to put a minus here, and I'm going to end up with what? 1 minus sine of theta in the numerator, because again, I'm going to multiply by 1 minus sine of theta here, 1 minus sine of theta here, and then down here it's the same thing, right? It's the same thing, so it's going to be 1 minus sine squared theta, okay? So let me erase this, and let me slide this over so I get my formatting right. Slide this over just a little bit, put equals there, and again, I can write this with a common denominator, so you can even do this real quick right here so we save a little bit of time and a little bit of effort. So let me just put 1 minus sine squared theta like this, and then I'll put this as 1 numerator with a minus here, but be very, very careful. When you're subtracting this away, you're subtracting away the whole thing. So go ahead and wrap that in parentheses to remind you that you need to change your signs because you're subtracting the whole thing away. Okay, so let's keep going and see what's going to happen here. So I'm going to have 1 plus sine of theta. Again, you're distributing this negative. So minus 1, distribute the negative here, so plus sine of theta, okay? And this is over 1 minus sine squared theta. So what can we do here? Well, we see immediately that this is going to cancel, okay? So now I basically have 2 times sine of theta. So 2 times sine of theta over 1 minus sine squared theta. Now, remember in the hints, we saw that 1 minus sine squared theta was cosine squared theta. Again, if you go back to this, if you have this guy right here and you just subtract this away, so 1 minus sine squared of theta would give you cosine squared theta. So if we come back here, I can replace this with cosine squared theta. So let's go ahead and do that. So I'm going to put equals 2 times sine of theta over the cosine squared theta, okay? Now, is this getting close to what we want? Let's go back up and see where we are. We have 2 times the tangent of theta times the secant of theta. So are we close to that? Well, I see I have the 2. I need the tangent of theta and the secant of theta. So to get this, I'm going to break this up. Remember, cosine squared theta can be written as cosine of theta times cosine of theta, okay? It's just this times this gives me cosine squared theta. Now, up here I have 2 times sine of theta. Now think about it. If I have sine of theta over cosine of theta, that's the tangent of theta, okay? And if I have 1 over cosine of theta, that's the secant of theta. So I already have what I need, okay? You just need to break things up so you realize what's going on. So I'm going to put this as 2 times sine of theta over cosine of theta times 1 over cosine of theta. And then I'm just going to, again, replace this with what I'm looking for. So in this particular case, it's going to be what? 2 times, this is going to be the tangent of theta, times, in this case, this is going to be the secant of theta. And now the left side and the right side perfectly match. So I'm going to go ahead and put my check mark there. And again, I'm done. All right, let's take a look at one final problem. And this guy's going to be pretty challenging overall. So I encourage you to pause the video and try this on your own. But before you do so, I want to just give you a little hint that you basically want to get both of these to a common expression. Okay, so you want to work on one side, get it down to in terms of sine and cosine. This side is pretty hard if you are not used to working with these. This side's pretty easy. Okay, so you want to get it to this common third expression. So go ahead and pause the video and try it. And hopefully you did give that a try. And I'm just going to start with the left-hand side here. Okay, so I'm going to start by just taking this guy and trying to write it in terms of sine and cosine. So how can I do that? Well, let's start out by just putting that we're working on the left-hand side. Okay, some teachers want you to do this, others don't care, so just get with your teacher. And I'm going to first copy the left-hand side. So I have the secant of x plus the tangent of x over the secant of x minus the tangent of x. Now, lots of ways to do this. I'm going to go through one that is probably not obvious if you haven't worked a lot of these problems. Remember, the secant of x, by definition, is equal to 1 over the cosine of x, okay? So if I multiplied this secant of x, which is 1 over the cosine of x, times the cosine of x, I would get 1, okay? So in other words, if I did this guy right here, let me just copy this real quick. So secant of x plus the tangent of x over the secant of x minus the tangent of x. If I multiply this guy by the cosine of x over the cosine of x, when I distribute this here, this is going to be 1. When I distribute this here, this is going to be 1. Another benefit is when I distribute this here and this here, think about the fact that the tangent of x is the sine of x over the cosine of x. So the cosine of x is going to cancel in each case. So I'm going to end up with 1 plus the sine of x and 1 minus the sine of x. So that's pretty simple, okay? So that's how I'm choosing to do this. Again, you could arrive at this a different way. So let me just put equals over here. This multiplied by this is going to give me 1, okay? And then plus, let me just write this out. So the tangent of x times the cosine of x. We know we can cancel that further. And then we have, again, cosine of x times secant of x is 1 minus, we'll have the tangent of x times the cosine of x. Okay, so from here, I'm going to, again, keep simplifying. Let's put 1 plus, I'm going to do sine of x over cosine of x times the cosine of x. Again, this is going to cancel. So this cancels with this. And this is over. Let me get some more room here. I think I'm going to run out. So we have 1 minus, again, I'm going to write this as the sine of x over the cosine of x times the cosine of x, okay? So this is going to cancel, and I have the sine of x there, okay? So let's just write this one more time. We'll put 1 plus the sine of x over 1 minus the sine of x. So that's pretty simple. It's in terms of sine, okay? And basically, now what I want to do is try to get the right-hand side to match this, and you're going to find that that's pretty simple. So let me start a new sheet here. And I'm going to say the right-hand side. Okay, and let me make that a little bit better. So let me put the right, and I'm going to try carefully to write this. So right-hand side. Okay, penmanship is hard for me. So let's come back up, and let's think about this guy. So we have 1 plus 2 times the sine of x plus sine squared of x over cosine squared of x. So let's come down. So we have 1 plus 2 times the sine of x plus sine squared of x, okay, over, we're going to have the cosine squared of x. So the first thing is, you should be thinking about factoring when you see this pattern. Again, this is basically where you have x plus y quantity squared, right? It becomes x squared, so first guy squared, plus 2 times the first guy times the second guy, so 2 times xy, plus the last guy squared, okay? That is exactly the pattern you have here. This is going to be basically 1 plus sine, okay, of x, quantity squared. So I'm going to take this guy, and let me do this properly. So let me just kind of slide this down a little bit, okay? I'm going to put equals. So I'm just going to say this is 1 plus the sine of x, quantity squared, over your cosine squared of x, okay? So I'm going to put equals over here. So what am I going to do with this now that I've factored it? Well, again, if you see something like cosine squared of x, and you see something in terms of sine of x, I want you to think about the fact that this can be replaced with 1 minus sine squared of x, okay? So I'm going to write this as 1 plus sine of x, quantity squared, over, this is going to be 1 minus sine squared x. So at this point, some of you are thinking that there's something weird going on. This doesn't match this, but it will in a second. This is the difference of squares, so you need another factoring pattern here. This is 1 squared, basically, minus sine squared x. So I'm going to rewrite this, and then it's going to be completely obvious what's going on, okay? So first, let's go ahead and write this as 1 plus sine of x times 1 plus sine of x. Okay, so I'm just expanding this. Nothing illegal about that. I have an exponent of 2 there, so I'm allowed to do that. Okay, then down here, I'm going to factor this as 1 plus sine of x times 1 minus sine of x. And now it is completely clear what I'm doing. Okay, so this cancels with this, and I have 1 plus sine of x over 1 minus sine of x. Again, if we go back, what did we have here for our left-hand side when we worked it? 1 plus sine of x over 1 minus sine of x. So what I'm going to do here, I'll just put equals 1 plus sine of x over 1 minus sine of x. And to complete this guy, you might just want to write your basically 3 expressions here. So I'm going to say that the secant of x plus the tangent of x, so plus the tangent of x over, and I don't know if I can fit this all on the screen, but I'm going to try. So the secant of x minus the tangent of x, let me scroll this down and try to write smaller, is equal to, we have this 1 plus the sine of x over 1 minus the sine of x. So this is what we found from working the left side and the right side. Okay, so this is your basically your common third expression. Okay, and this is going to be your 1 plus your 2 times sine of x plus sine squared of x. Let me see if I can scooch this down just a little bit more. And then over, you had your cosine squared of x. Okay. So this is going to basically do it for this guy. Again, you're not going to probably see too many of these if you're on a basic test. You're probably going to get maybe one of them towards the end. They realize how much time these guys take, okay? So if you get something where you're just working and working and working on one side, you can't get it anywhere, go ahead and get it in terms of sine or cosine, stop, and then start working the other side. See if you can get it to match.